waited for about 45 minutes, and I'm like,
Oh, I was at the meeting
oh.
from 9 to 2.
It's okay.
But what do you want to talk about? Just now being in class?
Well, yeah, man. I was just like, hey, I gotta go.
Are we about to do that like again today?
Well, we're going to, you guys miss a lot, we start a new chapter. Okay, we start a new chapter. Okay. And we play the game.
I guess so. I wasn't here.
You were not here? Okay. I'm going to review a little bit what we learned because a lot of you were not in class. Hope you guys had a good Thanksgiving. You had a good one?
It was good.
No? For the first time I cooked the turkey. It was very successful.
Yeah.
Yes, I'll tell you about it. Okay, so we are going to talk about chapter 10. Okay? And chapter 10 will be on the final exam. Will be on the final exam. Will be. And chapter 10 is on the game theory. What is game theory? Game theory actually is it's a mathematical methodology that different disciplines has incorporated, has adopted in order to analyze and do whatever they want to analyze. Okay? And you guys have watched the movie The Beautiful Mind?
Yes.
By Russell Crowe? Okay? You did not, you got to watch that movie after the final, it's a great one. And in that movie, and the main character is what? You remember?
Did you just say it?
The main character? Yeah, what?
I can't remember his name, but
It's John Nash. He right? He was a mathematician. He's still a mathematician. Actually, he's still alive. You know, I had a photo with him.
Hey, isn't he cool?
Yes. And so he was a founding father of the game theory. Okay. And so basically, what game theory? Okay, listen to me. So what the game theory basically is, it's a methodology that we can use to analyze and make prediction about different parties' action. Okay, and also we can use it to predict the outcome. Okay, as long as game theory as long as the setting satisfies the following three conditions, then we can use game theory to analyze. The first condition is we have to have more than one party. You have to have more than one party in the setting or the environment. Okay, pay attention, all right? Especially the ones when we're not here on Tuesday. The second condition is each party pursues its own interest. There must be more than one party, and each party must pursue its own interest. And the third one is each party's action has impact on others, but no one can dictate the outcome. So everyone's action is going to have impact on the other players, but no one can dictate the outcome. As long as those conditions are satisfied, then we can use game theory to analyze. For example, presidential campaign. There's more than one candidate there, right? And each candidate pursues his or her own interest, which is what? To become elected as president. And each candidate's action or speech is going to have impact on how likely others are going to be elected. Okay. So we can use game theory to analyze the presidential campaign. Okay. Biologists also use game theory. Okay. Use game theory to analyze how the cells interact with each other. The cells in our body is like living things. Okay, and we're going to use game theory to analyze the firms in the oligopoly setting. Okay, because in the oligopoly setting, there's more than one firm. Each firm pursues its own interest, which is to maximize their profit. And one firm's action is going to influence the other firm's profit, but no firm can really dictate the final outcome. Okay, so that's why I'm introducing game theory, because game theory is really very helpful in analyzing the economic parties' action and the interaction with each other and predict the outcome. All right, so let's look at the example here. This example is a duopoly, so we have two firms. And this is two airline companies, United Airlines and the Continental Airlines. And these two airlines participate in the competition, and this competition is a price competition. And also it is a competition that is a simultaneous move competition, which means, and the company is going to make the move simultaneously. Okay. So they are competing on the route, from Washington D.C. to Beijing. Okay. They have two strategies to choose from. They can either offer discount or no discount. If they offer discount, then the ticket price will be $1,000. If no discount, the ticket price will be $1,500. Okay, each one of them has two strategies to choose from, and they're going to make the decision simultaneously. Okay. So we're going to have 4 possible outcomes, right? Okay, 4 possible outcomes. So I'm going to give you the values in those 4 possible outcomes. Then we're going to determine what will be the final outcome, how each company is going to behave. Okay. Okay, suppose they offer no discount. None of the company offer discount. No discount. And they're going to split the market. And each one of them is going to make $1.2 million. So the left number represents the profit made by the United Airlines. The right number represents the profit made by the Continental Airlines. Okay? You guys with me? What if both guys offer discount? Again, they're going to split the market, but the profit is going to be smaller. Okay. And the profit is going to be 0.8 for each guy. $0.8 million for each guy. What happens if one guy offers discount, the other guy does not? One guy,
The one offering discount higher profits.
the one offers discount is going to get all the customers. The other one is going to make 0. Everybody is going to buy the cheaper ticket, right? So if UA offers no discount, Continental Airlines offers discount, then UA is going to make 0. The other guy, Continental Airlines, is going to make $1.6 million, and vice versa. 1.6 plus 0. Everybody understand the situation here? Okay, now let's apply the game theory. We want to use the game theory to analyze how each player is going to play, which strategy each one going to choose, and also we're going to predict outcome. Okay, so the game theory tells us the following. If we are trying to figure out UA strategy, we have to fix the other guy's strategy. Fix. Let's say, Continental Airlines choose to offer discount. We fixed. So we're just looking at this column here. Now what is the best thing for UA to do? Discount or no discount?
discount.
Discount?
Yeah.
Why?
Because they'll make the same amount of money as they will.
Because otherwise it wouldn't make anything.
Look at number here. Use a number to speak. Okay. If we fix the continental airline strategy like this, then UA by choosing discount can make 1.8, right?
Yeah.
If they choose no discount, it will be 0,
Yeah.
right? So this is better. Let's fix continental airline strategy again. If continental airline offers no discount, the best thing for you to do. Now we're looking at this column here. Nehemiah,
Offer discount.
over discount. Because 1.6 is better than 1.2. So what does this analysis tells you? What you should do?
Offer
Over
discount.
discount. Because no matter how the other guy is going to behave, it's always best for UA to choose discount, right?
Mhm.
So we call this is a dominant strategy. Dominant strategy. Dominant strategy. Dominant strategy it says that no matter how the other players play, you always have the same best strategy. Then that's what we call the dominant strategy. So UA has a dominant strategy. Okay. Okay. Now let's figure out what the Continental Airlines strategy. How do we do it now? Using the game theory method I just used. How did I figure out UA?
You fix.
You fix.
You fix, right? So now we got to fix UA strategy, right? So let's say UA choose to offer discount. Then we're looking at the first row here. What's the best thing for Continental?
Offer discount.
Offer discount because 0.8 is better than 0.
Yep.
If UA choose to offer no discount, then what's the best thing for Continental Airline?
Offer discount.
So, Continental Airline also has a dominant strategy. So what is the outcome in this game? What is the outcome?
They're both gonna offer discounts.
They're both going to offer discount, and each one is going to make $0.8 million. And that this here, discount and discount, is what we call Nash equilibrium. And it's here. And it's an outcome with where both numbers are marked underneath.
You said UA has the dominant strategy?
Both have.
Oh,
Do you guys follow the procedure there?
yeah.
Okay.
Can you explain it one more time?
Explain what one more
From
time.
the beginning, how you fix UAN and how you fix continents.
When you look for the US strategy, you have to fix the other guy's strategy. Let's say you look at here, you fix this guy's strategy. Okay? To figure out what you have to do, then you compare these two numbers, right? By choosing discount, you can make 0.8. This is better than that, right? So you choose discount when Continental Airline choose the discount. So you have this number here, right? Okay, then let's fix again. Suppose Continental Airline choose to offer no discount, then you look at this column here, right? Then what's best for UA to do? By choosing discount, they can make 0.6. By choosing no discount, they can make 1.2. This is better. So you mark this number. Okay, so this equilibrium here, we call the Nash equilibrium because each player is playing its best strategy, even the other player's strategy. Each one is playing its best. Okay. However, is this ideal outcome? Is this ideal? No. There's outcome there, 1.2, 1.2. If they both know for discount, they're both going to be better off, right? But if we just have this one-shot game, they both going to maximize their own profit. We will never end up with here. Right? That's what we call the prisoner dilemma situation. Even there is a better outcome. Even there is a better outcome. but they will never end up with here because each one of them is truly choose to maximize their own profit. Isn't it right? What kind of situation, what kind of setting will change that will make both players to reach this outcome?
They have agreement together.
They have what?
Agreement. Like they have.
No, that's price.
That's
I
price
don't know.
fixing. It's good stuff. We're gonna talk about that. Okay. If they collude, if they collude, they say, okay, let's do that. Let's know the, CEO call each other. Okay. Let's offer no discount when the time comes. Suppose you're the CEO for Continental, you're the CEO for the United. You talk on the phone. Yeah, you talk on the phone. Because if it is explicit colluding, it is illegal. It is illegal. Okay, price fixing is illegal. But let's say you did not do the explicit. You just call on the phone, have a chat. It's, offer no discount when time comes. But then you go separate way. When the time comes, what are you gonna do? You're the CEO of your United Airlines. Your goal is to maximize your own firm's profit, and also this is a one-shot game. There's no future.
And I'm not sure he will do as our promise or not.
That's right. You do not know. So what's your best strategy?
With this kind of
Discount. Exactly. Okay, but how can we change the setting to make these two guys to keep their promise? In the reality, is it just one shot game? You're never gonna see each other again? Not true, right? After there's a future, right? So when we have multiple rounds, when we have multiple periods, then there's another issue kicks in, that is reputation. Okay, so later we're going to talk about what if we have multiple periods in this game. How that's going to change the parties, the players' behavior. That's really going to change. Okay, so if there's a future waiting for you, then you may not want to cheat. You may not want to break the promise because you have to consider about your future profit as well.
But if there were a promise in the beginning at all, it would be price fixing, right?
Yes, it'll be price fixing. Yeah. It is illegal, but the company do that.
I have a question. How the government find out they are illegally doing this privately?
They look at the price.
But what if they occasionally come together, reach the same price?
Occasionally,
Not intent, not on purpose to do it.
if it's not, there's no intention. Okay, if there's no intention, you're talking about it randomly. They're kind of close. Then there will be data to support that. Okay, so basically, what those, if the government sue them, okay, there is a chance that you guys are doing the price fixing. Those company will go to economic consulting firm or hire economists like me. Okay, so government has this lawsuit against us. So please, this is our the prices in history, and that's what's the information provide you. Then the economist will do a model analysis to prove that you guys are not doing the price fixing. Okay, yeah. So there's a lot of work. That's what economic consulting firm does, is to to prove those firms are not doing the price fixing. I was interviewed by the it's called what's his name, Cornerstone Research in Washington D.C. and they particularly focus on the price fixing case. Okay, one of the questions I asked them, they said, what if your conclusion is that this firm is doing the price fixing? What are you gonna do? I asked that question because that's my question. What if the firm tell you they are not doing price fixing, but what after your analysis you're not convinced about that?
That's your question to them, or theirs to you?
That's my question to them. So I asked that.
Change the data?
Then they answered me. They said we always bring whatever result to the court. Whatever we come up with, going to bring to court. See, eventually, in the court, there's a companies, economists, and also the government. They all going to, argue back and forth whether there is a real price fixing or not.
What if the company giving money to the?
You see, the inside story, I would not know because I never worked there, right? Okay, that's always, I suspect, it's really the true story that you presented in the court. Because you can really tweak. Just change one equation, change one number different, then you're gonna have different result.
Sketchy.
We do not know, okay, but that's what they do, okay. Okay, alright, so everybody understand how do we find Nash equilibrium here, right? Okay, I'm going to give you a couple more examples to practice this methodology here. Price fixing cases are very interesting, are very challenging, okay? If you, pursue economics, PhD level, and you could end up a job doing that, and it's not a cash.
Take your word for it.
The starting pay is 150
I believe it.
for the entry PhD graduates.
Let's still take like 30 years PhD.
However, you have to expect like 60 to 70 hours work per week. So there's no free lunch in this world, So if you can, so most of people do it is get a couple of years experience, just move, jump. That's what people do. Alright, so let's look at this. I'm going to present you another game. What do we call this? It's called a normal form representation. This matrix here is called normal form representation. Okay. We'll have two players, A and B. Actually, we don't need. Okay. A and B. Then each one has two strategies to choose from. H and L for A, B is L and R, okay? Then here's the payoff. Okay, this is a simultaneous move. I want to ask a couple questions from here. Does A or B have dominant strategy? Yeah. Do you work on it?
Yeah.
Okay, first answer the question, does A have dominant strategy?
I'm not sure I'm looking at.
Wait.
A.
Yes.
Does A have dominant strategy? Which means no matter how B plays, there's always the same best strategy for player A.
No.
Does A
I don't think so.
Yes.
Is that R or H?
A for A, right?
We're talking about A's.
Yes.
Does A have dominant strategy?
So no matter B how
No matter how B plays, there is always the same best strategy for player A. Does it have?
yes.
And what is it?
H.
H, right? Because when B choose L, the best thing to do for A is H, right? When B choose R, the best thing for A to do is still H, because 15, right?
Okay.
So A has a dominant strategy. Okay, now I want you to take a look at the B. Does B have dominant strategy?
Don't get hung up on L or H.
Does B have dominant strategy? B does not have dominant strategy.
Nah.
You guys see that?
No.
I still don't see how A has dominant strategy.
I'm sorry, I am not getting this. Can you just go back over how you're supposed to get a dominant strategy?
I cannot go back from very beginning. Okay,
I'm not
but
saying from the very beginning, I'm talking about this problem.
okay, the problem is, okay, we're figuring out whether A has dominant strategy, so you have to fix B strategy. Look at here. So when B choose L, we're looking at this column here, right?
Okay.
Okay, what's the best thing for A to do? Choose H or L?
H.
I'm asking H. Why? Because 10 is better than minus 10, right?
Yes.
Okay, when B choose R, what's the best thing for A to do? H? Why? Because 15 is better than 10.
Okay.
Got it?
Yes.
So that's why A always choose H. But now we're trying to figure out B strategy, so we have to fix A, right?
Uh-huh.
When A choose H, what's the best thing for B to do?
It's,
Christopher? See whether you understand. Follow here. When A choose H, when we fix A now, what's the best thing for B to do? Look at here. Now we're looking at a row here. Okay? By playing L, B get 20. By playing R, B get 8. Which one is better? L. So you mark it. You see the way I do it? I mark it every time I find the best one. Okay? Now, if A choose L, what's the best thing for B to do? Johnson.
R.
It's R.
Yeah, because it's
Yeah.
10
That's
is greater.
right.
10
So-
is greater than 7.
That's right.
Okay.
So does B have a dominant strategy?
No.
No, B does not, because it depends on how A plays, right? His best strategy changes.
Okay.
So
I'm sorry. So just so I understand it. So if you're fixing B, you compare the bottom number and the top number. So 10 and negative 10. You're comparing those two. If you're fixing B. And
That's
then
right.
if you're looking at R, you compare 15 and 10. Is that correct?
that's right.
Oh, wait.
Yes, that's right. You were right. Yeah.
Okay.
When we fix B,
When we fix B, that means we're trying to figure out A strategy.
A, but when A choosing H, 10 is less than 20.
I'm just thinking.
No,
It's
10,
B's.
20 is not A's payoff.
Oh, yeah. Wait,
She's confused. Right?
She's switching up the numbers.
Okay.
I think it would help if you
Label.
label
Use
the
different color markers.
different color markers.
Yeah,
I mean,
different color markers.
the left-hand side is always going to be the left-hand number, and the top number is always or the top number.
But you will get used to it.
But yeah, it's,
Okay, so do you guys get the gist of it?
Yeah.
Alright, so A has dominant strategy, but B does not. Do we have a Nash equilibrium?
No.
No. Yeah, yeah. Yeah.
Yes or no?
Yes, we do. It's 10 and 20.
Do we have the Nash equilibrium?
Yes.
Yes, we do. Both numbers marked underneath, so this is our Nash equilibrium. What is Nash equilibrium? Given one player is doing, the other one is playing his best. Okay. So this is your Nash equilibrium, because when B choosing L, the best is for A is choosing H. When A choose H, the best thing for B to do is choosing L. So that's why both numbers are marked underneath, and that is Nash equilibrium. Okay, let's do more practice. The more you practice, the easier it becomes.
on the test, are you gonna give us a chart like that?
Yeah. It's once you practice, you understand it's really not hard.
I was making sure it wasn't gonna be like a word problem.
And then there will be a word problem. You know me. There will be a word problem.
No. Oh, wait. Will the final be the same amount of questions, or will there be?
We will talk about final next class.
Oh,
I forgot we were in class.
cause our final is Tuesday.
This way?
Yeah,
Tuesday.
like next Tuesday.
Okay. So
Finances Wednesday.
Just checking, I'm pretty sure.
Like for us to fill out a chart.
But I know it's not cumulative.
okay, look at this.
So fix it.
100, 100, 100, 100, 0, 0. Does A have dominant strategy? Does A have dominant strategy? When B choose to play L, what's the best way to do?
It's your H.
When B choose R, what's the best thing for A to do?
L.
So
No.
does
Yeah, L.
No.
Yeah.
Neither have.
No, not yeah.
No,
when B choose L, the best thing for A to
To
do
do
is
A.
H,
Yeah.
because 100 better than 0, right?
Uh-huh.
When B choose R, the
Doesn't
best thing
matter.
for A to do is L,
Well, yeah, true.
because that 100 better than, so does A have dominant strategy?
No.
Okay. So we figure out what A is going to do. How about B? Okay, let's figure out B. And we're fixing A strategy. Okay, let's say, we're here.
Okay.
What's the best thing for
L.
B to do? When it's here,
R.
does B have dominant strategy?
No.
No. In this case, neither one has dominant strategy, but we have Nash equilibrium.
Yes.
Right.
How many?
2.
That's right.
Okay.
See?
And the reason why they have, is it, you said Nash or Nash? Is it
Nash.
Nash. Okay, so Nash equilibrium is when they both have their like specific way of doing it, right? Because
The definition of Nash equilibrium is important. Let me repeat the definition of Nash equilibrium. Nash equilibrium, if a strategy profile is Nash equilibrium, that means given the other player's strategy, and each player is doing his best. Look at this one.
Oh, because they're both right.
H, L. Okay, A play H, B play L. This is Nash equilibrium. Why? Because when A plays H, the best thing for B to do is play L. When B plays L, the best thing for A to do is choosing H. That's why this is a Nash equilibrium. Given the other player's strategy, each one is playing its best.
Okay.
Can you go over this dominant thing one more time?
Dominant strategy. Okay. Let's see whether A has dominant strategy now. So we have to fix B, right? If B plays L, what's the best thing for A to do? H. Because 100 better than 0, right? If B chooses R, what's the best thing for A to do?
For L.
It's L.
Yeah.
So it changes. So A's best strategy depends on how B plays.
Mm-hmm.
So that's why it does not have dominant strategy.
Okay. Yeah.
Dominant strategy means it's always the same, no matter how other players plays. Okay. Let's do one more practice, and I think you'll,
We'll do it.
getting more and more comfortable with that. This time, I'm going to have a story behind it. Okay. This is what we call the bargaining game. It is a bargaining between the union and the manager. Okay? Bargaining is this. They have this $100 to split between these two sides. Okay, they want to split this $100. Okay? And each party, either union manager, going to write down a number on a piece of paper, and this number represents how much they want to take it home, from this $100. Okay, and the only 3 numbers they can choose from are this. Put 0 there. That means they take home 0, and either all 50 or 100. The rule of game is this. If the sum of these 2 numbers is less than or equal to 100, then each party take home that money. So if union put down 50, the manager put down 50, and the sum of it is equal to 100, so each one of them is going to take home $50. Okay? However, if the sum is greater than 100, then they take home nothing. Not only they take home nothing, they have to give up $1. Okay. So I want you to think about how do we put those payoff here based on that story. So each one of them has 3 strategy truth profile. If the sum of the 2 numbers is less than or equal to 100, they're going to take home that much money. If the sum is greater than 100, they could take home nothing, but they're going to lose $1.
Is it less than or equal to 100?
Less or equal to 100. Okay, so what is the payoff here?
0, 0.
0.
for both guys, right? What's the payout here?
0.
What's the payout here? 100 0, right? What is payout here?
0,
0, 50.
0 50?
50,
50 50? How about here?
100.
Zero,
No.
zero.
It's
Zero,
0, 0.
Yeah.
It's voided.
Yeah, it doesn't matter. It's still
You
gonna be greater
mean
than
greater than
100.
100 or 200?
What's this payout here?
If you got a put
150. 150.
payout 0.
Negative,
Because you broke the
Negative
rule.
one.
negative 1, negative
What
1.
is the pair? So who said negative 1, negative 1?
Oh, yeah.
Ah,
Right.
And lose $1.
okay.
And here?
100, 0.
No, 0, 100.
0 100. This one?
Negative 1 and 1.
This one?
And then negative 1 and 1.
Okay? The same idea, same methodology. Choose C. Does the manager have dominant strategy?
Yes.
Then we're going to fix the columns now, right? Work on this yourself on the notes.
Oh, yeah.
Each one would take 50.
Okay.
Well, no, they pay.
I'm so. What about that one?
It's,
Yeah, there's no double track.
you should say the right way. There's a dominant strategy or not?
No.
No.
There's no dominant strategy.
Yeah.
Because I could eat plus.
Yeah.
Okay, so when this, we're gonna do the marking like what we did. Because only through do the marking we can figure out the Nash equilibrium, right? So when the union choose to this strategy, what's the best thing for manager to do?
100?
100.
We'll mark here, right? Okay. When union choose 50, what's the best thing for manager to do? Okay. When union choose 100, what's the best thing for manager?
0.
Alright. Now let's fix manager, figure out union. When manager choose here,
So, 0. Or
0, 0.
100, 0.
here,
Yeah.
right?
Mhm.
Okay. You have to mark the correct number, okay?
Right.
And when we're here,
50,
what is the
50, 50.
50.
Uh-huh.
this one, right?
Yes.
When we're here, what's the
0.
okay?
Yep.
Do we have Nash equilibrium?
3 of
3.
So both, all of the three are Nash equilibrium. And look at the nature of the Nash equilibrium.
Yeah.
100 0. No, look at the strategies. 100 0, 50 50, and 0 100. So that's the strategy, not the payoff. The strategies. Okay. Okay. So what it tells you that, okay, if you know one guy, you know the manager is going to choose 100. The best thing for you to do is choose 0. If you know the guy is going to choose 0, the best thing for you to do is choose 100. That's why this is Nash equilibrium. Given the other player's strategy, you're choosing the best.
When the manager is fixed, why I cannot pick the 0, 51 and the 0, 0, 0, 1?
When what?
When we are
Which
manager
strategy?
is fixed.
Manager is fixed, okay. Let's say manager is choosing this, then the best thing for you need to do is
This
100.
Yeah.
100 is better than 0. You mark here.
Alright. See.
Oh, I got it.
Okay, so now, so this shows you we can use game theory to predict this kind of bargaining situation. Now, I'm going to give you a story. It's very similar to this bargaining. And I want you to find the Nash equilibrium in this game. Suppose I have this $1 to split with Chase. $1 to split. And I'm gonna write down what I want in a piece of paper. He's gonna write down on a piece of paper how much. Okay? I can write down 0 or 1 cent or 2 cents up to $1. But you can write down 0 too. Okay. So how many strategy each of us has? How many strategies each of us has?
100.
Be accurate. How many?
101.
Yeah,
101.
101.
Because you include 0.
Zero.
Right. Okay. So we're not able to use this because we have 101 strategies. It's going to take forever to draw, right? So that's why I cannot, but you can, and you understand logic behind it, we can do this. Okay, and the rule of game is this, the similar. If the sum of these two numbers we write on a piece of paper is less than or equal to $1, then we take home that much. Okay, but if the sum is greater than $1, we take home nothing. That's it. What is the Nash equilibrium in this case?
The line.
What are the Nash equilibrium in this case? Everybody understands dollar here, right? The speed dollar. Okay, I can write down anything from $0 to $1, and he's the same way. And if the sum is less or equal than $1, we take home that much. And if it's greater, we take home 0.
So it'd be 50-50. It's like
0,
100.
100.
0, 100 or 0, 1?
0.
Where's the dollar? Well, we don't have $100.
0,
0, 1. He said 50-50. Which one is right?
Oh.
How about what else?
There's like
Oh,
There would be 100 different.
101
right.
different.
So you're asking which would be the most logical
No,
choice?
which is
I'm asking you what are the possible Nash equilibrium?
Yeah, how many choices do you have?
All the points
You-
across that line.
You have 100 choices?
101.
And you have 100.
If I'm going to put this question, I'm going to ask you first, does each player have dominant strategy?
no.
Okay, no. Okay. Now, how many Nash equilibrium we will have? How many?
101.
Or 100.
It would be 50 different ways.
It'd be 100.
You have 101, right? Because you'd have 0 and 100.
We got 49, 51.
No,
Then you'd have
just
the other
100.
100.
Is it
199?
100.
It's either 199
No,
or
no, no,
101.
101.
Run there down those three.
How many?
101.
I say 100.
0, $1, 1, 99, 2, 98, until
0,
dollar
0.
0, until dollar
Oh.
0.
So you got 100.
So you got 101 Nash equilibrium.
Call
101, right?
Just throw numbers out there.
Depends on how many colors.
But so that now you understand what is Nash equilibrium. Given one strat is best, you play his best. And that's why 50 cents is Nash equilibrium. Because if you know the other one play 50, you better play 50. If the other guy knows you play 50, and that's best strategy for the next one. Okay? So good. We're doing good with time. Alright, so this is the first section of this chapter. And this first section of this game series stuff is on the simultaneous but one-shot game. So players move simultaneously. So when we choose a number, we choose the same time. I cannot see his number, he cannot see my number, right? Okay. So this is simultaneous move game, and also it's a one-shot game, which means there's no future concern to worry about. So now we're going to expand. We're going to talk about the simultaneous move, but repeated game. What if the game is repeated several times? This stuff is fun.
Oh,
It's fun. It's actually, once you figure out, it totally makes sense. It's not that hard. So now, simultaneous game. There is this one-shot game. Is what we just talked about. Then we have infinitely repeated game. Repeated game. Okay. Then we have finite repeated game. So that's the three games we're going to introduce. We already talked about one-shot game. Next, we're going to talk about infinitely repeated repeated. So the game will be repeated forever.
Forever.
Let's see. No. Okay, so each guy has two strategies to choose from. Alright, UD for A. Okay, let's suppose we have a one-shot game. So let's analyze. If it's one-shot game, okay, what is the Nash equilibrium in this game? You figure out for me right now. If it's one-shot game, what is Nash equilibrium?
10.
Do the marking. Okay, do not look. Even me, after doing game theory for almost 10 years, I still do the marking myself. You're just learning. Do the marking.
Alright, so
Bless you.
Thank you.
Do the marking.
50 without the negative one.
Yeah, this is the 50 minus 40 minus 40, 50, 10, 10, 0, 0.
and the equilibrium would be 0, 0.
Okay. Okay, do you guys get it?
Yeah.
What's the Nash equilibrium? 0, 0, right?
Mm-hmm.
It's UL, right? This is because when you fix B,
Right.
this is better. When you fix R, this is better. When you fix A here, this is better. When you fix A here, this is better, right? Okay. So we have Nash equilibrium.
Okay, that's right.
And if you look at this is not the ideal situation. This is what we have called prisoner dilemma, right? Because they could end up with a better outcome, but they will never do it in a one-shot game. Okay, we have prisoner dilemma. Okay, now, what we want to know is whether this outcome could be different if the game is repeated infinitely.
If it's repeated
Infinitely.
infinitely, then
Infinitely.
Why would it make a difference?
Exactly. Why would it make a difference?
It wouldn't.
collusion.
Repetition.
Now let's look at the strategy, possible strategy profile. Okay, what I'm gonna do in here.
Merger and acquisition.
Okay, so baseline they represent a strategy, first theory, second, third, fourth, forever, right?
Mm.
Okay, and in each one, this guy has two strategies, truthful. You guys with me? Okay, so A could be choosing U. B could choosing L. The second could be D, R. The third could be UL, could be UL again.
So you're just
So how many possible strategy profiles there?
Four.
Four?
Well, yeah, you only there's only 4 strategies, but you can do them over and over again.
that would be you
So
you
in each round, each guy has 2 strategies to choose from. Right?
Mm-hmm.
So just in one round, you're gonna have 4 possible different outcomes.
right.
Then the next round, you're gonna have another 4 possible outcome, right? But how many periods you have?
Infinite.
Infinitely. So how many possible outcomes we're gonna have?
Infinite.
Infinitely. So that's why we were not able to use this kind of metric box or normal form representation to represent the possible strategy anymore. Because there's infinite number of the possible strategies. But we're not interested in all of them. We are interested in the possible Nash equilibrium. And particularly, we are interested in this. Because we know this is the ideal outcome, right?
Mm-hmm.
Guys with me? We know this is ideal, right? A play D and B play R, both better off.
Yeah.
So we're interested in this. We know if it's just one shot game, this is not possible, right? It is
Right.
not equilibrium.
Right.
But we're interested if this game is repeated infinitely, whether this is a possible Nash equilibrium. If it is, then we're happy. Which means the cooperation can happen if there's a future, and there's many future to come. Okay, so this is one strategy, possible strategy we're interested in. So we're going to see whether this is a possible Nash equilibrium. in this report.
Is it legal to acknowledge the fact?
No, we're not going to have cooperation. So it's not going to be a price fixing. It's totally competitive. But they're choosing they're choosing their best strategy. But their best strategy like that. So they're not cooperation. Is what you're trying to ask him?
I'm not sure. I wasn't. Yeah. I'm
Okay.
following.
Okay, but before we talk about this, everybody's with me here? Before we talk about this strategy profile here, I want to ask you guys, what is one Nash equilibrium that is very easy to identify? Not this one. There is a strategy profile that is obviously a Nash equilibrium. What is it? What is it?
UL.
Each A play U forever, B play L forever. Is it Nash equilibrium?
Mm-hmm.
Yes.
If A plays U forever, then it is best thing for B to play L forever, right? If B play L forever, then it is best for A to play
Right.
L forever.
Yeah.
So we know this is one Nash equilibrium,
Mhm.
but we're not interested in
So-
this one.
So I mean, what's the objective?
Like,
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 to define Nash equilibrium for infinite.
the objective here is we want to see whether cooperation is possible if the game is repeated
Okay.
many times. We just talk about in the one-shot game, the firm will never have this cooperation outcome. They will never end up with this 10 times.
Okay. Yeah. Right.
Okay, but now we want to see whether this cooperation outcome can happen if the game is repeated many
So we're
times.
trying to get to R and D.
We're trying to see whether DR is possible.
Oh, yeah. Okay.
DR possible for the
Yeah.
repeated game.
Okay.
You see what I'm saying?
Yes. Mhm.
Okay, alright. So, okay, so now everybody knows this is one possible Nash equilibrium.
Yep.
Let's look at this. Oh no, it's D. Okay, so we're looking at this principal strategy. So we want to see what kind of situational setting can support this one as equilibrium. If we don't have a kind of regulation or don't have some rules for the settings or environment, this one is not going to be a Nash equilibrium, right?
Right.
So we have to have some rules that apply to this game. These rules we're going to use here, we call the trigger strategy. So this is basically trigger strategy says this is the rule we apply to this player's behavior.
If they were to go to R and D.
That's right.
Okay.
The rule says this. Each guy is going to play cooperatively, continue to play cooperatively, unless they see this one guy start cheating.
Okay.
Okay, so A gonna play D. As long as they see the other guys playing R, they're gonna continue. But once they say the B is deviating from here, is playing L, then from the next round, then A is going to play L forever. That's the kind of the trigger strategy, the rule we apply to this setting here. So basically, we set a punishment rule. If you cheat this round, then I'm going to cheat from the next round forever. Okay, so that's the kind of settings we are looking at. Okay, let's see whether this trigger strategy we talk about can support this as a next sheet. Everybody understand what I'm doing here? Okay. So basically we apply some rules for the off equilibrium path. So if you deviate from the equilibrium, there will be punishment waiting for you. Because of that punishment, that's why you don't want to deviate.
Okay.
That's why you stay on equilibrium path. So
Okay.
instead, so in order to encourage both guys to stay on the equilibrium path, we have to set some rules for the off equilibrium behavior.
Okay, so D and R they're in equilibrium, correct? So
Yeah.
if they were to go, if
they-
company B were to go off, let's say
Yeah,
L or U or
there will be punishment
Right, okay.
waiting for it.
Got
And because we have that punishment waiting for it, that's why both guys will
Right.
not deviate. Okay.
okay.
So let's see whether this punishment works. Okay, we have to see whether this punishment works. If anybody has a question,
I have a question,
Sure.
just to make sure. So you said your trigger strategy is, for example, if A cheats one time, then B would cheat all the rest of the times.
that's right. From next
Okay.
time, from next round, we gonna cheat forever, forever.
I have a question. How can they reach B and R?
How come what?
How can they like reach it before they
In a theoretical sense.
because both of them will 0 and 0 are their Nash equivalent. So before they reach 10, they have to like go through all of the minus 40 and 50. So how can they reach 10 at the beginning?
Well, I'm gonna show you why they're gonna play 10-10. I'm gonna show you, okay, why this trigger strategy works.
Oh.
When a certain situation.
But it's just like in a theoretical sense, because they wouldn't do this in real life.
You reach an agreement.
They do really not. What we are trying to
There's a lot. I mean, think about it.
imitating. If you think about it, it's basically just a punishment rule.
Yeah. No, I
If you
understand
get
that.
off, that's what we see in the real world. But we just use a game theory to kind of analyze why that's how each party works. Okay. So let's see whether the trigger strategy works. So we're going to look at each player's strategy at each round. Okay? Let's see, look at A. For A, each round, they have two strategies to choose from. I'm gonna say if they cooperating, they're going to end up with 10, right? Okay. But if they cheat, what is they gonna get? What are they gonna get if they cheat?
Minus
Minus
40.
50.
Oh,
If
50
A
first
cheat,
time.
if A cheat,
They're gonna get
50.
50.
they can get a 50.
50, yeah. But that's
Right?
only for one time.
That's right. Okay. So they're gonna get, if they cheat, they're gonna get 50, but they're gonna get 0 forever, right?
Mhm.
Mm-hmm.
But if they don't cheat, they will get 10, then get 10 forever. Right? Now let's look at the benefit of cheating. Compare with the cost of cheating. If the benefit of cheating is less than the cost of cheating, then I will never cheat. What's the benefit of cheating?
40 one time.
It's 40, right?
Uh-huh.
they can get 15 instead of 10, so they basically have $40 surplus, right? 40. So the benefit of cheating is 40. But what is the cost of the cheating? They're going to lose 10 from the next round and forever, right? Okay. So is it going to lose 10 next round? Then what is the
No,
present?
it's worth it after 40 periods. It's not, or 4
No,
periods.
4 periods.
Okay,
Depends
we
on how
have
it lasts.
it's infinitely repeated game.
Yeah.
So you're going to lose 10 and you're going to lose 10 forever. Okay, so what is it? You guys have taken finance course before, right? You learn the present value.
It's cost capital.
Okay, so you're going to what is the present value of that loss if you're going to lose 10 from next round and forever? How do you
More
calculate?
than 10.
10
That's,
to
yeah, I mean, it depends on probably around 10.
More than
You guys have learned that, right? What do we call that?
Infinite sum.
Perpetuity?
Oh.
That's what I was thinking.
What's
I mean,
that?
Is it perpetuity?
That's what I was
Time
thinking.
Perpetuity. Yep,
Perpetuity.
perpetuity. Okay, how do we calculate present value of perpetuity?
I don't remember.
Oh, it's
Let's see
it's
for
it's
It's net.
minus something.
Okay.
It's on.
Alright.
It's the value.
If it starts, okay, if start from the next round, which is in the call of your case is this, then the formula is this. Whatever the loss each round divided by the interest rate. So you're gonna lose 10 from the next round and forever, and the present value of that loss is 10 divided by interest rate. Interest rate. So this is your benefit of cheating, $40, just one time gain, and your loss, the present value of your loss is $10 divided by I. So if this $40 benefit of cheating is less than 10 divided by I, you're gonna cheat or not?
not
You're gonna not cheat. So then solve this. So you move I to the other side. I has to be less than 10 divided by 40, which is 25%. So this tells you if the interest rate is less than 25%, if the interest rate less than 20%, then we can have this strategy as a Nash equilibrium, supported by this trigger strategy.
So the I is less than 25%, we will cooperate it.
Yes, we can have DR as a Nash equilibrium with support of the trigger strategy. You have to have this support.
If it's more than 25%, go ahead and cheat.
Go ahead and cheat.
Oh, okay.
Do it.
Go ahead and cheat.
So under this situation, then we may see the cooperative outcome exist.
Pretty good.
Alright, cool.
Okay, make sense?
A lot easier than the other chapter.
Actually, this it's
A
not
lot
that hard.
easier.
We have 15 minutes. So what you need to do is, when you solve the problem, you construct this box here. That's just one for the one-shot game. And then you determine what's the Nash equilibrium and also what's the cooperative outcome. Then because if you look at this number here, this is the difference between these two here, right? And this 10 here is the outcome of what? Okay. So why don't we just try a book problem, see whether you guys can follow that. Okay, look at the page 141. Page 41. Page 41. Question 4. This is a normal phone game. It's like this. 70, 70, 0, 60, 60. Okay? First, identify the one-shot game Nash equilibrium. Should not be hard to do. What is one-shot Nash equilibrium? It's A and C, right? Okay, alright. Next, suppose this game here repeated infinitely. With the interest rate is 6%.
6%. Wait, 30%.
Okay, then I want to ask you whether we can have a Nash equilibrium where player 1 play B, player 2 play D forever. Interest rate is 6%.
Plus 6%.
Okay, follow the procedure there. Figure out the cost of the cheating, figure out the benefit of cheating, then compare the two. You're gonna use the interest rate to figure out the cost of cheating. It should not be hard to do.
30 is.
What is okay? First, what is the benefit of the cheating? Brandon,
The benefit of the cheating?
cheating? Yeah.
Not really sure right now. I just brought the problem up.
Okay, just a good part.
Yeah.
Okay, who else?
Is it 40? 10?
10.
Where is it? Okay, the benefit of cheating, if they
They do cheat. It's
if they do cheat, they will get what?
10.
70.
They do get 70, but
70.
it's plus 10 more.
So the benefit of cheating is just 10,
Just 10.
Just
Yeah,
10.
Just 10.
Minus 6.
right?
Yeah, just 10.
Okay,
7 or 1?
okay.
70.
If they cooperate, they're gonna get 60, right?
Yeah.
If they don't cooperate, then they end up with
With
70.
70,
So
which
the
is 10.
difference is 10.
Yeah.
So the benefit of cheating is
It's
10,
10.
right?
Mhm.
Right.
You're gonna compare the difference of the payoff from two strategy, okay? What is the cost of the cheating? So what's the number you put in here? You're gonna lose how much from next round forever?
10.
60.
Wait.
You're gonna lose how much?
60.
30.
Oh, yeah,
30.
30.
Is it 30?
30.
It's 30, right? Because that's cooperative outcome. You're gonna lose 30 from next period and forever. And the interest rate is 6%. Then tell me whether
So 5 is less than 30.
the benefit of cheating is 10. And the cost of cheating is equal to 30 divided by 6%, which is equal to
30 divided by
30 divided by 6%, which is equal to. Is it? Hold on. Is it 6%?
Yeah.
I don't think you mean percent.
It's 500, right?
Yeah, 500.
Okay, so which one is bigger?
500.
530.
Cost of cheating is it's bigger.
Yeah.
So what's your conclusion?
Don't cheat.
Don't cheat.
Don't cheat or cheat.
You do not.
Don't cheat or cheat. Cost of, I mean, this cost of cheating is bigger than the benefit of cheating. Are you gonna cheat or not?
No, you did not cheat.
You're not gonna cheat. So if you're not gonna cheat, we can have a equilibrium, Nash equilibrium, which is BD forever, right?
Mm-hmm.
So everybody understand this?
It did this. That's what they did.
So what do you do with the
You see a lot of you know, the people who figured out is doing it on their own. You have to use this. So in this case,
yeah,
That's the way I'm looking at it.
and here,
Exactly.
You divide by percentage.
so
Yeah, cause it's a percentage, so it's really.
this will be 30 divided by 6
This is like, this is you were trying to get the
So
hero.
and is lesson.
Okay. So, hero will be here forever.
So we will have
After you
an actual equal.
And why is it 30 again?
Yeah, 60.
30 divided by 0.06.
So cost of cheating is what you're gonna lose from the next round
We're doing
forever.
Okay.
This was later on.
So,
It's a good question.
yeah, well,
It's a good
because.
question. Because if you cooperate, you're gonna get 60. But if you cheat,
You're gonna get 70.
then you're gonna get 30 forever instead of 60 forever. So the difference is 30.
60 minus 30 equals
60 minus 30.
Sweet.
And then obviously 10 minus 0. 6%, right? Yeah, 6%. But you're wrong. 10 minus 0.
I'm sure you guys practice couple times.
So is it because that it's the fallback Nash equilibrium? That's why we pick 30, or is it?
Okay, if you do not cheat,
Yeah, do not cheat.
you're gonna get 60
Right.
forever.
Right.
If you cheat, then from the next round you're gonna get 30 forever. So what you lose is $30 from next round
What he's
forever.
asking is why is it 30 forever?
Because if they choose the other, if the other guys choose the other thing, they're gonna get 0.
If you cheat this round, then the next round the other guy's gonna cheat, then both guys gonna cheat.
So then
Then you're gonna end up with one shot Nash equilibrium.
Right. That's what we're trying to like.
Okay, so going back to our last example, the cost of cheating was 10.
Look at this.
There's a difference between the two.
Oh, okay.
Right?
Gotcha.
It's always
Okay.
a difference between
Yeah.
these two.
Okay.
The cost of cheating, the number of, on the numerator is always the difference between these two.
Got it. Okay, thank you.
That's why I just.
Half of you are following me, half of you are not. I can tell from your face very well.
Okay.
But practice this. And what I want you to do is homework, book problem 1 and 2 and 3, and you can do it. And I want you to do this practice. You don't have to turn in, but I want you to do it. And we're gonna talk about next class. It's a practice. 1, 2, 3. 1, 2, 3. I'm trying to not give you, but I do want you to practice because otherwise you will not know how to do it. 1, 2, 3.
I think we got it.
Okay. Yeah. Practice this. Okay. Then we talk about it. We still have more stuff to talk about.
So
No. This and also.